Welcome to this edition of Math Dive in About 5. I'm Barbara Knox.
And I'm Daryl Frost. Welcome.
Today we'll be focusing on graphing in the first quadrant. Here is your first task. You might want to get out some blue and yellow color tiles and create the patterns that you see on the screen. Then create a T-chart that shows the number of blue and yellow tiles as you increase that pattern. Create a line graph to show the data. What's the scale? What are you going to represent on the X and Y axis? And how many yellow tiles are there when there are 10 blue tiles? See you back in a few minutes. Here we have the progression with VEST, and you can see on the slide it jumps from 3rd to 5th grade.
Sure does. I don't see anything in grade 4.
But I want you to consider what you've done with number lines, because on a coordinate grid, the X and Y axis are basically a horizontal and a vertical number line that intersect at point 0,
which is
on both of those.
Origin.
So
both
there are
connections to geometric figures.
All right. We're going to be focusing today on the 5th grade benchmarks. So here you see the coordinate grid with all 4 quadrants. We have quadrant 1, 2, 3, and 4. In 5th grade, they only focus on quadrant 1,
which are positive numbers.
Correct.
Or positive integers.
So we're going to look at quadrant 1 in 5th grade, where we're only working with the positive numbers on the X and Y axis. The origin in both of those is at point 0, 0.
That identifies the origin.
Where those 2 number lines cross at point 0.
The location of the origin, if you will.
Take a look at some of the vocabulary that they're going to encounter in this unit.
Yes.
We have the origin, which is at point 0, 0, where those 2 number lines, the horizontal and vertical number lines, intersect. We have the x-axis, which is that horizontal number line, and the y-axis, which is the vertical number line. And in this unit, students are going to be working with coordinates. So when you're thinking about an XY coordinate, I want you to think about a ladder, right? We climb a ladder.
Right.
But before you climb that ladder, you have to get to the ladder.
Right.
So I want to think about a person at the origin, and they are going to walk to that ladder. So we're going to walk to point 6 before we can climb 5 rungs. And we land at coordinate 6, 5.
That ladder is a really good way to conceptually think about when they say, you said sometimes you see run, rise. It's you walk or you run to 6, and then you still have to climb 5 rungs on the ladder. So it gives it context.
It just gives you a visual, right?
Yes.
If I can think of a ladder out in front of me somewhere, I have got to walk to that ladder in order to be able to climb it.
That's a good connection.
Here's a task they might encounter either in instruction or on an assessment, where they're being asked to make a rectangle, and they're given 3 coordinates,
right,
but asked to find the 4th.
Okay.
So first they're going to have to plot those first 3 coordinates. I'm going to figure out where 4, 7 is, where 6, 7 is, where 4, 2 is.
So it looks like a rectangle to me.
I've got to visualize that rectangle to figure out where my 4th coordinate would be. Once I find that 4th coordinate, I have to be able to name it. And I walk to the 6 and I climb to the 2.
So you're applying that, and it could be any 4-sided polygon.
It could be. It could be a parallelogram or a rhombus. It could be a triangle.
Yes, right.
Here are a couple of additional tasks they may encounter. So here I am starting at a certain position and I am moving on the coordinate grid and having to find the landing point. So if I start at 4, 5, I find that coordinate, I move up 3, I move right 2, and I have to determine where I land. That landing point is at walking to the 6, climbing to the 8.
There you go.
And the next one, I am starting at 210. I move left 1, down 6, right 8, up 3. They could give any number of directions to find that landing point. And the landing point here is walk to the 9, climb to the 7.
And students could trace that with a pencil too.
Yes.
Those directions.
Yes. So now going back to the original task that you worked on, you probably built these with blue and yellow color tiles. With my first term, 1 blue, there were 8 yellow tiles. With 2 blue, there were 10 yellow tiles, and so on and so forth. You had to think about how that pattern continued each time you were adding 1 blue tile, and there were 2 more yellow tiles, right? We'll be talking about the rules.
Because I'm seeing a rule right now, but we're not there.
But we're not talking about the rules during this unit. The rules come in play in the next unit.
This is just graphing these as coordinate pairs.
Correct. We will come back to those rules and this same task in our next Dive in 5 video. So you would have continued building and finishing the pattern up to 10, because we did ask you how many yellow tiles there were when there were 10 blue tiles, and now we know that there were 26. The next thing that you were asked to do was to create a line graph to show the data that you had in your frequency chart. And to make a line graph, you need an X and a Y axis, and you need to determine the intervals for each of those.
And that's where it can be a challenge for 5th graders.
And you want to also label. So I'm going to do my blue tiles on the X axis, which means what am I going to put on the Y axis?
The number of yellow tiles.
And the number of yellow tiles, I'm going to use a different scale. I'm actually going to use a scale of 2 on this one.
Well, if you look at them, it's like 8, 10, 12. That makes sense.
And then you were going to graph the points. And as it increases, you're starting to see a line.
A line.
Correct.
And a rule, but we're not there.
We're not there yet. So here I see my trend line. So here are a couple of misconceptions that can occur in this unit. I think we've already addressed that first bullet point with the ladder.
The ladder.
Right.
Yeah.
We've got to walk before we can climb. And also not understanding what that value of 0 represents.
It's a location.
It is a location, and it is along the origin, either at the origin when it's 0, 0, or along the X or Y axis.
Right. And the origin is an intersection of the lines.
Correct. So in thinking about how you might make this a concrete experience, you can create a coordinate grid on the floor, either outside on the court or in your classroom with painter's tape.
Yes.
Create a physical grid that students can actually walk on as they create their ordered pairs.
And that would help with the walk and the climb.
Yes, it would. Representational thinking, they're going to use paper pencil with maybe a pre-labeled grid, and you'll start with a blank grid with your abstract thinking.
Where they're having to determine the scale and so forth.
Which is my X, which is my Y. Thank you for joining us for this edition of Math Dive in About 5. We'll see you back next time.